An earthquake is a natural phenomenon that claims many lives every year. However, a common misconception is that the earthquake itself is fatal. In reality, it is man-made structures which are not built to resist earthquake loads that are the real cause for the loss of life. Earthquakes are the explosive propagation of built-up energy between tectonic plates through the Earth's crust. The movements of these plates is a result of the process in which the upper layer of the Earth, the lithosphere, moves with the flow of the soft asthenosphere. This is caused by the temperature gradient across the Earth due to the dense hot core and the lighter and cooler surface. In 2017, a magnitude 7.1 earthquake struck Mexico, causing a loss of 225 lives. As a team, we looked at the civil engineering failures related to this disaster.
On average, it is estimated that there are 500,000 detectable earthquakes each year. Of this, 100,000 can be felt, however, only 100 cause damage. When an earthquake occurs, it is possible for the building to oscillate, and this is called the period of oscillation. The taller the building, the larger the period of oscillation. The effects of some earthquakes include landslides and tsunamis. A strong column and a weak beam design can be used to prevent the failure of buildings. Some earthquake-resistant structures include brace frame structures and base isolation system. When designing a building, it is important to consider wall-to-roof connections, wall-to-wall connections, and wall-to-foundation connections.
A frequent result of earthquakes is landslides. This happens when the load applied to the slope becomes higher than its capacity to resist the load. However, this capacity to resist the applied load depends on the nature of the granular soil. In consequence, to understand how this concept applied to the earthquake in Mexico, we applied different loads to a sample of soil from the area. We recorded all the different dimensions of the artificial slopes we created in the sealed container before and after applying the load. We then plotted the final repose angle of the slope in function of the force applied in g. The average line we were able to trace from the plotting gave us insight onto how soil behaved during the earthquake and how it will behave under future earthquakes. Evacuation has always been crucial in the event of earthquakes, volcanic eruptions, or other similar natural disasters. For most of the buildings and public places, evacuation plans were established to ensure people's safety and to reduce the amount of casualties during an emergency. We had an opportunity to draft out the evacuation plan for the Azteca Stadium located in Mexico City, simulated under the conditions of the Mexican earthquake in 2017. We have also separated the stadium into various sections and allocated them with 5 safe zones around the stadium. After running through calculations on pedestrian flow and traveling speed, we have concluded that the evacuation time would be approximately 5 minutes for each exit of the stadium. Throughout this workshop, we have developed our understanding towards the importance of evacuating people out of structures in an effective way.
Through this challenge, we have developed an understanding of engineers in preventing the loss of life in these disasters. And so, by taking into account these factors, we hope to prevent further loss of life to the devastating impacts of earthquakes.